In factoring a trinomial of the form ax squared plus bx plus c, the goal is to find the two binomials, the px plus q and the rx plus s that can multiply together and equivalent to the ax squared plus bx plus c. We look at the two cases for factoring a trinomial. Case 1, the leading coefficient or the a equals 1. And the case 2, where the leading coefficient a is not 1. For the first part, or the leading coefficient a equals 1, we have x squared plus bx plus c. The expanded form that we saw above on this page, the middle term, the coefficient is simplified to be s plus q, where the product of the q and the s is the same as the value c. Therefore, when you have the leading coefficient equals 1, you're going to find the two numbers that the product is the c. And then these two numbers add together as a sum, like q plus s equals the b. For case 2, the leading coefficient that a is not 1. First, we're going to multiply a and c together and then factor b into a plus c. If no such factors exist, the trinomial is irreducible. If it is irreducible, we also call it prime. So after you multiply a and c and then factor b into the a plus c, so we're going to rewrite the bx, which is the second term of the trinomial, into the sum of the ax and the cx, and then factor by grouping. Basically, you have ax squared plus bx plus c. You're gonna rewrite the b as the sum of a and c. So a plus c multiplied by x expanded to be ax plus cx. At this point, you're gonna have like 4 terms of this original trinomial. After you obtain 4 terms, you're gonna do the grouping technique to factor them. Take a look at the examples. In part A, we're gonna factor x squared plus 3x minus 28. The leading coefficient a is 1. So put a note here, a equals 1, b equals 3, and c is negative 28. So we are going to look at the pair of the numbers that the product is negative 28. That means one of them is positive, the other one is negative inside. But the sum of these two numbers would be 3, which is the value b. So we look at the pairs of the numbers. As b is positive, so that means the greater quantity gonna be positive inside. So the number that product is 28 could be 1 times 28, 2 times 14, 4 times 7. Looks like 4 times 7 is the winner. So since the larger quantity gonna have positive inside, so gonna be positive 7 times negative 4. And let's check. Positive 7 minus 4 equals 3. So we got the pair of the numbers. Now we bring it back to the part of the problem. So this one becomes the quantity x as the first term, x plus 7 times x minus 4. And we are done factoring for this expression in part A. For part B, 12y to the second minus 17y plus 6. In this case, the a is 12, b is negative 17, and the c is 6. A is not equal to 1, so then gonna be case number 2. What we're gonna do for part B to factor is we're gonna look at the two numbers that from the product of the A and C. So start with the A times C, which is 12 times 6 or 72. For the number 72, we're going to break it up. Excuse me. For example 4, we're going to factor the algebraic expressions. In part A, we have x squared plus 3x minus 28. Identify A as 1, B as 3, and C as negative 28. In the case that A equals 1, we're going to look at the pair of the numbers that the product is the C value, which is negative 28. So this negative 28 would be the two numbers that multiply, but the sum equals the value B, which is 3. So we could have like multiple pairs that the product is negative 28, such that negative 1, 28, or 1 times negative 28, 2 times negative 14, negative 2 times 14, and then 4 times negative 7, or negative 4 times 7. But we're going to look at the pair of the numbers that the sum equals 3. The first one, the sum is not 3, not 3, not this pair, but this is negative 3. The last one, yes, is 3. So this is the winner. That means for the x squared plus 3x minus 28 can be factored as x minus 4 times x plus 7. Second part or part B, 12y squared minus 17y plus 6. Make a note here, the A equals 12, the B is negative 17, and the C is 6. Since A is 12 not equal to 1, we're going to start off with multiplying A and C, or multiply the number 12 and the number 6 turns out to be the value 72. And then we're going to find a pair of the numbers that the product is 72, but the sum equals the B, which is negative 17. So the 72, we can make it as the product of the two numbers and see which pair is the right pair for our problem. Since the sum B is negative 17, negative sign, that means the product of these two numbers gonna be the same sign as negative sign. So start with the lowest one, like the negative 1 and 72, not the right pair, so we can ignore this. And next, negative 2 and 36, not quite. Negative 3 and 24, and negative 24, sorry. And the next one, negative 4 and negative 18, not quite. Negative 6 multiplied by negative 12. Again, the sum is not negative 17 yet. The next one will be negative 8 multiplied by negative 9. Yep, that's it. This is the pair that we are looking for, that the sum is negative 17. So once we get the pair, we bring it back to the main part of the problem and then rewrite the negative 17 as negative 8y minus negative or minus 9y, and then plus 6, because negative 17 is from negative 8 minus 9. After we get the 4 terms, we're going to perform factoring by grouping. by by grouping the first two terms and the last two terms, 12y to the second minus 8y plus negative 9y plus 6, and then find the greatest common factor of each group. The first group, 12 and 8, the greatest common factor would be 4. Y squared and y, the lowest power is y. So 4y is the greatest common factor of the first group. Then the remaining factor for the first group will be 3 for the number and y to the first power for the variable factor. Then subtracted by 2, since 4 times 2 is 8, and then y to the first power already factor out. For the second one, we have negative 9 and 6 as the numbers. So the greatest common factor of negative 9 and 6 would be the value 3. And then the remaining factor gonna be negative 3 times y and then plus 2. Looks like opposite terms again. So we're gonna have the property that we apply the negative side or factor the negative side out of the second group. This one becomes negative, 4y times 3y minus 2, and then subtracted by 3. And then inside the parentheses, the sign will be opposite. So it becomes 3y minus 2. At this point, we see the common factor as 3y minus 2. So we factor it out, 3y minus 2, and multiply by the remaining factor of the first group, which is 4y. The remaining factor of the second group is negative 3. So at this point, we obtain the factor form of the 12y squared minus 17y plus 6.